So good afternoon all. Now we are discussing the last lecture of the unit number 6, that is a problem based on the stability of the side slopes. Okay, so I have prepared the formula sheet for the same. Okay, so as we know that in this whole chapter we are going to find out the stability of the slope, means we are going to find out the factor of the safety against the sliding. Okay, so this factor of safety that can be calculated, the basic formula is that is the maximum shear strength of the soil to the maximum shear stress along the potential failure. Okay, so these are the formulas. The first formula, that is the factor of safety with respect to shear strength. This is the basic formula, that is Fs equal to S upon tau. S is the maximum shear strength upon tau is the maximum shear stress along the potential failure. So formula is based around the Mohr-Coulomb law, that is S equal to, that is shear strength, that equal to C plus sigma tan phi. C is the cohesion, sigma is the normal stress, phi is internal friction, upon mobilized cohesion, means the value of cohesion and internal friction. So the formula will be same, that is C plus sigma tan phi. So here instead of C, here we can use Cm plus sigma tan of phi. Then factor of safety with respect to cohesion is the ratio of cohesion to the mobilizer cohesion, that is Fc equal to C upon Cm. So C is a cohesion due to strength and Cm, that is a mobilizer cohesion. Then factor of safety with respect to internal friction, that is angle of internal friction, it is the ratio of angle of internal friction to the mobilizer angle of mobilized internal friction, that is tan of phi upon tan of phi m. So phi is internal friction and phi m, that is the mobilizer internal friction. Then factor of safety with respect to height. Okay, so it is denoted by letter Fh, while the internal friction, that is F phi, and for cohesion Fc. Okay, so you can use the Fs later also. Okay, there is no problem. So here I am using, that is Fh for height, F phi for internal friction, and Fc for the cohesion. So for factor of safety for the height, that is Fh equal to H upon Hc, that is original height upon the critical height. Then we had discussed, that is analysis for the infinite slope for cohesive as well as cohesionless soil. Okay, so in that there are 5 cases we have discussed. The first case, that is infinite slope, that is factor of safety for infinite slope in a cohesionless soil, but the soil is dry soil, that is infinite slope in a sand with the dry soil and there is no water content. So our factor of safety will be tan of phi upon tan of beta, that is tan of phi is the angle of internal friction and beta is the slope angle. Okay, that is a slope angle. Then second case, that is a factor of safety for that is infinite slope in once again in a cohesionless soil, but there is water table, that is fully submerged condition is there. So the factor of safety is tan of phi dash upon tan of beta. So tan of phi dash, the phi dash, that is effective angle of internal friction, and beta is angle of slope. Then factor of safety in the sand when the seepage is parallel to the slope, and water table which is occur at any depth. Okay, and the soil is cohesionless soil. So formula is Fs is gamma submerged upon gamma saturated into tan of phi dash upon tan of beta. So phi dash, that is effective angle of internal friction, beta, that is slope angle, gamma submerged, that is submerged unit weight, and gamma saturated, that is a saturated unit weight. Then the factor of safety once again in infinite soil, factor of safety for infinite slope for cohesionless and cohesive soil, that is C phi soil for the cohesive soil as well as cohesionless soil, that is C soil and phi soil, that is cohesive and cohesionless soil, that is Fs equal to C upon, C is cohesion, upon gamma into Z is the depth, into cos of beta, sine of beta is a slope angle, plus tan of phi upon tan of beta. Then last, that is factor of safety for infinite slope in a cohesive soil, that is a clay, that is clay soil, that is C soil. So the same formula, that is our formula, only this parameter is as the phi value is phi is 0. So the same formula is, that is C upon gamma z cos of beta sin of beta. And next is Taylor stability number. Okay, so this is very important formula, that is Taylor stability number, that is Sn. So Sn equal to C upon gamma into Z into Fs. Now that this is important formula. So most of the problem in your competitive examination, when you are appearing for the various competitive examination, so problem based on this Taylor stability number might be asked. So Sn equal to C upon gamma Z F into S. So C is a cohesion, gamma is a unit weight, Z is a depth, that is depth of slope, and F is the factor of safety. Okay, so now we are going to solve the problem. So this is the problem number first. For a slope 10 meter height with a stability number 0.055, what is its factor of safety if gamma 20 kilonewton per meter cube and C 25 kilonewton per meter cube? Okay, so what is the given data? So first of all, write down the given data, what is the given data and what is required. So here is the height of slope, that is Z is 10, height of slope Z equal to 10, Taylor stability number, that is Sn is given, that is 0.055, then gamma is 20 and C is 25, and what is required? What is the required? What is the factor of safety? What is the factor of safety? Okay, as we know the formula for Taylor stability number, that is Sn equal to C upon gamma Z F into S. So where Sn, value of Sn is 0.055, value of C is 25 upon gamma is 20, Z is 10 and Fs is to be calculated. So value of Fs is 2.27. Okay. So next problem is second problem, an embankment is inclined at an angle of a 35 degree and its height is 15 meter. Okay, so an embankment is nothing but our slope. Okay, the slope angle, so here is slope angle beta is given. So while reading this problem, you have to write all the given data also. Height, that is depth of slope, is 50 meter. The angle of shearing resistance, that is the value of phi is given, that is 15 degree. Cohesion intercept, that is value of C is given 200 kilonewton per meter square. The unit weight of the soil, that is 18 kilonewton per meter cube, that is gamma is given. If the Taylor stability number, that is value of Sn is given, that is 0.06, find the factor of safety with respect to cohesion. Find the factor of safety with respect to cohesion. Okay, so this is given data, beta 35 degree, Z 15, phi 15, C 200 kilonewton per meter square, gamma 18, and Taylor stability number Sn. So here is so this is Sn, this is Sn. So previously you can take a screenshot or so what is the problem, and then we are going to solve. So we know that what is the formula, Sn. So Sn equal to C upon gamma into Z, C upon gamma into Z. So value of Sn is equal to 0.06 upon, so here instead of C, so we can write as Cm, we can write as a Cm. Okay, आपला फॉर्म्युला काय आहे, C अपॉन गॅमा इंटू झेड. मग आपण Cला CM म्हणू आपण इथे, कारण व्हॅल्यू आपल्याला मोबिलाइज कोएजनची दिलेली आहे ना. मग आता ती आपण पाहू आपण. मग त्यानुसार CMची व्हॅल्यू किती येईल, Snची व्हॅल्यू किती आहे 0.06, बरोबर ना. हे मल्टिप्लाय 0.06 इंटू 18 इंटू डेप्थ किती बघा आपली डेप्थ. हां, डेप्थ इज what is the depth, depth is 15 na, sorry, so here is into 50 na, so depth is 15. कळलं काय Sn equal to C upon gamma into Z. ओके, सो गॅमा किती आहे तुमचा 18, गॅमा इज 18, Z इज 15, Sn किती आहे तुमचा 0.06, त्यानुसार काय येईल तुमची व्हॅल्यू Cm. तो Cm किती आला तुमचा 16.2 किलोन्यूटन पर मीटर स्क्वेअर. ठीक आहे, तर आपल्याला काय दिलं आहे कोहेजन दिलं आहे ना बरोबर, कोहेजन दिलं आहे. तर आपल्याला माहिती आहे फॅक्टर ऑफ सेफ्टी विथ रिस्पेक्ट टू कोहेजन इज व्हॅल्यू ऑफ C अपॉन Cm. ओके, व्हॅल्यू ऑफ C इज गिवन दॅट इज 200. Cm किती आहे तुमची, Cm आताच कॅल्क्युलेट केली आपण 16.2. सो फॅक्टर ऑफ सेफ्टी विल बी इक्वल टू 12.2. फॅक्टर ऑफ सेफ्टी विल बी इक्वल टू 12.2. ओके, so next is third problem. Cutting is to be made in a clay for which the cohesion is 35 kilonewton per meter square and phi equal to 0. The density of a soil is 20 degree. So here first of all write down what is to be given. So here is a clay soil is given. The slope is clay, which is made up in a clay strata, that is okay, clay strata. So as the soil is clay means there is no internal friction, that is phi equal to 0. So value of C is 35 kilonewton per meter square. Density of the soil, that is gamma equal to 20 kilonewton per meter cube. Find the maximum depth for a cutting side slope 1:1.5 to 1, 1:1.5 to 1 if the factor of safety is 1.5, and take the stability number for 1:1.5 slope and phi equal to 0 as 0.17. Okay, so we have to use the simple formula. We know that the formula. Okay, what is the formula? We know that the formula. What we have to calculate it? We have to calculate what is the height of the slope. Okay, so we know the formula, that is Sn. So here I am writing Sn equal to C upon gamma into Z. Okay, so here we have to calculate value of Z. Okay, value of Z. So for that purpose gamma into Z into Fs is formula. So formula is Sn equal to C into gamma into Z into Fs. Okay, so the or this is or we know the basic formula, that is Sn equal to C into gamma into Z. It is a basic formula. Okay, it's a basic formula, C into gamma into Z. So we have to calculate the value of so here we are going to write the value of Cm, okay, sorry. So by using this formula, we know that is Sn equal to C into gamma into Z into Fs. Okay, so here put the value of C. What is the value of C? That is 35. You have to solve 35. Then put the value of gamma. What is the value of gamma? Gamma is 20. Then put the value of Fs. Fs is 1.5. Fs is 1.5. Then put the value of Sn. So Sn is what is the value of Sn is given. Sn is 0.17. Sn is 0.17. By putting this value, we get the value of Z. So once again I am writing it by clear words. So Sn equal to C upon gamma Z Fs. So this Sn is nothing but 0.17 equal to C. Value of C is 35. C is 35 upon value of the gamma is 20 into Z into Fs. So Fs is 1.5 Okay, from that calculate the value of z. Calculate the value of z. So we get the z value of z is that is height of or thickness of the slope, that is 6.86 meter. Then the problem number 4, that is homogeneous slope of a 10 meter high with the stability number 0.16. What is its safe height? If the gamma equal to 20 kilonewton per meter cube and c equal to 25 kilonewton per meter cube and fs equal to 1.5. Okay, so once again the same problem is there, and we know the formula Sn equal to c upon gamma z f into s. So put the value of Sn is 0.16 equal to value of c is 25 upon gamma is 20, then the z we have to calculate it, and fs is 1.5. We get the value 5.2. We get the value 5.2. We just only put the value in the formula. Okay, so this is very important formula, S equal to c upon gamma z into fc. This is Taylor stability number. So next, problem number 5, find a factor of safety of a slope of an infinite extent having a slope angle. Slope angle is nothing but the beta. Slope angle beta. The slope made with the cohesionless soil with phi equal to 30 degree. So this is case number first. This is a case number first. Because soil is cohesionless soil. What is the formula? We know the formula Fs equal to tan of beta. So tan of phi upon tan of beta. So tan of phi, that is 30 degree. Tan of beta is 25 degree. If we put the value, we get the answer, that is 1.238. Okay, as the slope is made up of cohesionless soil. Cohesionless soil is there is no water content is given. So we have assumed the slope is made up of cohesionless soil, that is value of c equal to 0, and there is no water contents, means the slope is made up of dry soil. So we know the formula for the first case, that is Fs equal to tan of phi upon tan of beta. Okay. Next is problem number 6, that is for infinite slope with the inclination of a 28 degree, determine factor of safety. Determine factor of safety at a depth of 3 meter. The soil has properties are gamma equal to 16.5 kilonewton per meter cube, c equal to 13 kilonewton per meter cube, phi equal to 32 degree. How will be stability effect if the slope is submerged? Okay, so in this stability effect if the slope is submerged. So as in the given problem, how will we identify which type of case is here? So as the value of c is given, value of phi is given, means the case 4, that is c phi case is given. So for c phi case, the formula is Fs equal to c upon gamma z cos of beta sin of beta plus tan of phi upon tan of beta. So value of c equal to 30 upon gamma. Value of gamma is 16.5 into cos of beta. Cos of beta, this means the slope with the inclination, that is 28 into sin of 28 into tan of phi. That is phi means the angle of internal friction, that is 32 on tan of 28, that is 2.64. Okay, and problem is asked, how will be stability effect if the slope is submerged. So in this case, gamma will be reduced to the gamma submerged. Gamma will be reduced to the gamma submerged as a result of submergence. And stability will increases the c and phi will increase, and the stability will be increased as the value of c and phi remains same. So next problem, that is determine the maximum depth in a soft cohesive soil if the excavation is done. Determine the maximum depth in a soft cohesive soil. Note that cohesive soil means the sea soil. If the excavation is done at the slope angle, means that is beta with the vertical, given that gamma equal to 20 kilonewton per meter cube, c equal to 65 kilonewton per meter cube, phi equal to 0, factor of safety equal to 1.25. So this is a case number 5th. Okay, that is purely cohesive case, the infinite slope for cohesive soil. Okay, for cohesive soil means the cohesion is present, phi equal to 0. So value of factor of safety is equal to c upon gamma z cos of beta, sin of beta. So C equal to 65 upon 20, value of gamma is 20 into Z. Value of Z is to be determined. Z is determined. Cos of 20, sin of 20, and here is value of Fs is 1.25. Okay, 1.25. If you calculate this value, your value is Z equal to 8.08. Then next is next problem, problem number 8. Calculate the factor of safety with respect to cohesion. Factor of safety with respect to cohesion of clay soil. Okay, this is spelling mistake. Slope laid 1 in 2 at a height of 10 meter if phi equal to 10 degree, C equal to 25 kilonewton per meter cube, gamma equal to 19 kilonewton per meter cube. What will be the critical height of a slope? What will be the critical height of a slope if Sn, that is Taylor stability number, 0.064? So first of all, we are going to calculate the slope angle, because the slope is laid at 1 in 2. So 1 in 2. So 1 in 2. So this angle we have to calculate it, that is tan of beta equal to 1 by 2, that is beta equal to tan inverse of 1 by 2. So we get the value of beta is 26.5. So from that we are going to calculate the value of Fc. First of all, calculate the value of factor of safety with respect to cohesion. Then we are going to correlate with the factor of safety with respect to height. So Sn equal to 0.064 equal to 20 upon 19 into 90, that is gamma, and Z is 10 into Fc. So here the Fc is 2.06. So this critical height is given by letter Hc, is given by Fh, is the factor of safety with respect to height equal to H upon Hc. So here we are going to Fh equal to Fc, assume that is Fh equal to Fc. So Fc equal to 2.06 equal to H is 10 upon Hc. So Hc equal to 20.06 meter, or by alternative method we can find Sn equal to C upon gamma Z. So Zc, that is Zc equal to C upon gamma into Sn. Okay ना, ही व्हॅल्यू तिकडे घेतली फक्त आपण, that is 25 upon 90 into 0.064 equal to 20.6 meter. The last problem, what will be the factor of safety? What will be the factor of safety with respect to average shearing resistance, cohesion and angle of internal friction? Okay, so here we have to calculate factor of safety with respect to strength, factor of safety with respect to cohesion, factor of safety with respect to angle of internal friction. So for that purpose, soil properties are given, that is phi equal to 18 degree, C equal to 32 kilonewton per meter cube, and similarly value of mobilized cohesion and internal friction, that is phi m and Cm is given, that is phi m equal to 30 degree and Cm equal to 21 kilonewton per meter cube, and average effective pressure, that is sigma, that is normal stress, 110 kilonewton per meter square. For the same value of mobilized resistance, determine following Fh, that is factor of safety with respect to height, then factor of safety with respect to angle of internal friction, so that value of C equal to 1, and factor of safety with respect to strength. Okay, so there are two cases. So first cases we have to calculate the factor of safety with respect to strength, factor of safety with respect to cohesion, factor of safety with respect to angle of internal friction, and second case for mobilized value of shearing resistance we have to calculate factor of safety with respect to height, factor of safety with respect to angle of internal friction, that is at that case C equal to 1, and factor of safety with respect to strength. Okay, as we know that is available shear strength, that is formula, factor of safety equal to C upon S upon tau. So S equal to, we know the S equal to C plus sigma tan phi, and tau equal to Cm plus sigma tan of phi m. बरोबर ना. Cm means mobilized cohesion, phi means angle of mobilized angle of internal friction. Okay, so I will available value of first case, value of first case ला काय दिले बघा, व्हॅल्यू काय दिले आहे, C equal to 32. ओके, इथे वर पहा, C equal to 32. सॉरी यार. So first case, so this is the value, these are the values. C equal to 32, C equal to 32, phi equal to 18, and the effective normal stress, that is sigma equal to 110. We get the value of S equal to 67.8. आणि टाऊ कसा काढतो आपण, टाऊला सेम फॉर्म्युला, सी ची इथे काय करतो आपण CM आणि सिग्मा टॅन ऑफ फाय एम. मग आता इथे व्हॅल्यू काय पुट करा फक्त, फाय एमची किती व्हॅल्यू बघा, फाय एम 30 डिग्री आणि CM 21. सो मोबिलाइज द शेअरिंग रेजिस्टन्स ऑफ सॉइल, टाऊ इक्वल टू CM प्लस सिग्मा टॅन ऑफ फाय एम. सो CM किती बघा 21, टॅन दॅट इज 110, tan of 13 that is 46.4 kilonewton per meter square. So for factor of safety with respect to strain किती आला मग आता, Fs equal to S upon tau, Fs equal to 67.8 upon 46.4 equal to 1.46. Now second calculate factor of safety with respect to cohesion. We know the formula, that is cohesion upon mobilized cohesion. So value of cohesion, that is 32, and mobilized, that is CM, that is 21. So FC equal to 32 upon 21, that is 1.52. Similarly, calculate the factor of safety with respect to friction. So we know the formula, F phi equal to tan of phi upon tan of phi m. So tan of 18, that is phi value is 18 and phi m is 13. All these values are given equal to 1.41. So now we are going to calculate the second case, that is for the same values of mobilized shearing resistance, what will be the factor of safety with respect to height. So this factor of safety with respect to height, that is Fs equal to Fh equal to Fc, means factor of safety equal to factor of safety with respect to height equal to factor of safety with respect to cohesion. ये कब मिलेगा आपको, with factor of safety with respect to internal friction, that is Fi will be equal to 1. So we know the formula, Fs equal to S upon tau, that is C plus sigma tan of phi upon tau. Tau की value आपण तशीच ठेवली, that is we can write as tau equal to C upon Fc plus sigma tan of phi upon Fy. सेम फक्त काय केलं आपण, त्याचा फॅक्टर ऑफ सेफ्टी आपण सेपरेट लिहिला आहे, बरोबर ना. C अपॉन FC म्हणजे फॅक्टर ऑफ सेफ्टी विथ रिस्पेक्ट टू कोहेजन, फाय अपॉन Fy म्हणजे फॅक्टर ऑफ सेफ्टी विथ रिस्पेक्ट टू इंटरनल फ्रिक्शन. याच्यात जर आपण व्हॅल्यू पुट केल्या, ओके, तर आपल्याला माहिती आहे फॅक्टर ऑफ सेफ्टी विथ रिस्पेक्ट टू स्ट्रेंथ किती आला आपला, 46.4 काहीतरी आला ना आपला, हां 46.4 टाऊची व्हॅल्यू आपल्याला, दिस इज व्हॅल्यू ऑफ टाऊ 46.4 इक्वल टू सीची व्हॅल्यू किती आहे 32 अपॉन FC प्लस 110 टॅन ऑफ 18 अपॉन Fy, कारण Fy आपण काय म्हणले इथं वर म्हणले बघा, Fy इक्वल टू दिस, Fy इक्वल टू 1, दिस इज Fy इक्वल टू 1. Okay, if you calculate the value by solving, we get the value of Fc, that is 32 upon 46.4 minus 35.8, that is 110 into 10 of 18. याचा आन्सर असेल 30.8. त्याच्यानुसार आपल्याला Fcची व्हॅल्यू भेटली 3. सो Fc म्हणजेच काय आहे, Fh, that is factor of safety with respect to height, that is equal to 3. Then factor of safety with respect to internal friction कधी भेटणार आहे, ज्यावेळेस Fc इक्वल टू 1 असेल, that is factor of safety equal to 1 असेल. सेम फॉर्म्युला मागायचा, दॅट इज हाच फॉर्म्युला वापरा, दॅट इज सेम फॉर्म्युला, दॅट इज टाऊ इक्वल टू C अपॉन Fc अपॉन C अपॉन Fc अपॉन सिग्मा टॅन ऑफ फाय अपॉन Fy. इथे टाऊची व्हॅल्यू पुट करा, सीची व्हॅल्यू पुट करा, Fcची व्हॅल्यू 1 पुट करा, सिग्मा 110 फायची व्हॅल्यू पुट करा आणि Fy काय तो कॅल्क्युलेट करा. ओके, दॅट इज टाऊ, दॅट इज 46.4, टाऊ दॅट इज 46.4 इक्वल टू 32 अपॉन 32 काय आहे तुमची, दॅट इज व्हॅल्यू ऑफ C अपॉन 1 प्लस 110 टॅन ऑफ 18 अपॉन Fy ओके. तो Fy किती भेटेल मग आपला 35.8 minus 46.4 minus 32, that is equal to 2.49. This is the factor of safety with respect to internal friction. So now we are going to calculate the factor of safety with respect to strength. Okay. Factor of safety with respect to strength कधी भेटेल आपल्याला, that is factor of safety is obtained when Fc equal to Fy. So this equation, his equation, हा जी equation बघा आपलं main equation, that is tau equal to C upon Fc plus sigma tan of phi upon Fy. इथे Fc equal to आपण काय करू, आपण डायरेक्ट Fy Fc आणि Fy काय सेम येतं, मग आपण डायरेक्ट याला Fs म्हणू. मग इक्वेशन काय आपल्याला टाऊची व्हॅल्यू किती आपलं 46.4 इक्वल टू सीची व्हॅल्यू 32 अपॉन Fs म्हणू प्लस 110 tan ऑफ 18 अपॉन Fs, कारण दोन्ही काय आहे Fc आणि Fy इक्वल टू सेम येतं, म्हणून आपण त्याला Fc इक्वल टू Fy इक्वल टू Fs म्हणू. दॅट इज 46.4 equal to 32 upon Fs plus 110 tan of 18 upon Fs. So Fs किती आलं तुमचा 1.46. Okay. So this is your end of syllabus. We are completing all the each and every part along with the problem solving. So next I am going to take a lecture on MCQ. Okay. Okay, thank you.